Right, so this week we're still looking at Unit 5, and we're going to focus on lessons 4 through 7. So this gets into, two-column data, different data resources, and then we got to talk about something called algorithmic bias. So you can see, if I click on the details, there's going to be 5 videos for you to watch. One is this one, and then there's 4 short code.org videos. You really should watch these. They kind of go into a little more detail about what I'm going to talk about. And you're just going to have the 2 assignments this week. So one's going to be your Cornell notes for lessons 4 through 7. You can find a link to that document there. The other one is going to be some MCQ practice. You're going to go straight to MCQ practice 5.2, which will kind of cover Unit 5 as a whole and get you ready for the assessments that you're going to look at next week. So as you are going through these, again, you're going to be doing some Cornell notes as I talk about this. We're starting off looking at lesson 4. This is going to go into 2-column data. So if you remember last week, we talked about different ways to visualize data, and we really talked about 1-column data, which was your bar charts and your histograms where you can create those buckets. When we're talking about 2-column data, we're talking about exploring 2 different columns of data at the same time. So again, there is this video, you should watch this. He kind of goes through how to do this in code.org so you can kind of practice. But there's 2 types of charts that we look at for this course in regards to 2-column data. One of them is called the cross-tab chart. So with a cross-tab chart, this is a table or chart that counts how many different combinations of values from 2 columns occur. So this is useful when you're trying to find the most or the least common combination of values, when you're trying to find patterns across 2 columns, if you're exploring 2 columns when 1 or 2 both are strings. It's really not useful if either column has too many values, right? So the chart would be huge and it's just not something that we can really look at. After the crosstab, this is an example of a crosstab. You can kind of see how it creates these different categories for us and these different groupings. And using these numbers, we can see, how many times there was a sporting dog breed that will live to 14 years. So it kind of gives us these summaries, and we can look to see like where things are falling, right? The other one is the scatter plot. So the scatter plot shows combination of values for 2 columns. This is useful for seeing patterns and trends between 2 values. And this one is useful when it's numeric data with lots of different values. Right? The only time it really doesn't help us is when there's lots of repeating values. So again, this scatter plot, it's a chart that displays pairs of numeric values for 2 columns to show possible relationships. Really what we're doing with both of these is we're trying to find trends, right? So we define trends as a general pattern showing how one variable changes as another changes. So again, we have 2 columns. We can look for trends using either a scatter plot or a crosstab. Ultimately, what we want to find is relationships, right? How 2 variables are connected or how they move together. All right, so we do get back into correlation. So what does it mean if 2 values are correlated? It basically means that one variable changes, the other tends to change in a predictable way. So again, it does not imply causation. It's just correlation. And then why could data show a pattern without explaining why it exists? Basically, visualizations reveal patterns but do not provide enough information to determine cause. So we need more data. We need to do more investigation if we want to get at, the explanation side of this. But kind of your takeaway from this is really that visualizations like scatter plots and crosstabs allow us to explore relationships between 2 variables. They help us identify patterns and trends, and they recognize correlations without assuming causation. So this is what a scatter plot would look like, in case you were curious. Over here they have an area. Over here, this is the admission number. So they're looking at, the size of the 48 states and how many students go to college from each one. Again, so there's a lot of numbers. It kind of helps us to do the scatter plot so we can see how this is lying, because we can kind of see, that as, even though these dots don't exactly, we can kind of see that there's a line going up from left to right. So as the size of the state gets larger, the more people going to college generally increases. Again, there's a correlation, but we can't say that it's necessarily causing it. So this chart, this will really help you when you're being asked questions on the AP exam and like which type of chart should you use. So really what you want to do is ask how many columns. If it's one column, you're looking at how many values, because if there's only a few values, you're going to go with the bar chart. If it's one column, but there's a lot of values, you want to go with a histogram. If there's two columns, again, we're looking at, are the values strings? So if they are strings, you want to go to a crosstab. If they're not strings, you're looking at how many values. So if it's not strings and there's only a few values, you're still going to do a crosstab, but if there's a lot of values, you're going to go to a scatter plot. So I would definitely take a look at this, kind of memorize this. It'll help you with some of the AP questions. Looking at lesson 5, this talks about big, open, and crowdsourced data. So this is really some terms that you need to know. So when we're talking about big data is extremely large data sets that require significant computing power to store and analyze that data. When we're talking about open data that's publicly available for anyone to access, use, or analyze. When we're talking about crowdsourcing, that's collecting information or input from a large number of people, often through the internet. So you can have combinations of these three things, but you need to know what each three mean and what they kind of represent. So again, open data, that's sharing data with others so that they can analyze it. It's publicly available. Usually governments, colleges, large organizations kind of create this for us. And the whole idea behind it is having this open data. It just helps us spread useful knowledge and creates opportunities for others to try to solve problems with it. When we get into crowdsourcing, we also talk about citizen science. So citizen science is scientific research that involves data collection by members of the public. So this is when we are asking others to give us information, right? It is a form of crowdsourcing. If you've taken, AP research here, one of the things that those students have to do is they have to put out a survey. Usually students will send it to teachers that they know and ask them to give it to their class, right? That is citizen science. We are trying to crowdsource data. We're trying to get people to give us data. The citizen science side of it is we're asking members of the public to give us this info, right? And then lastly, that big data, that's just huge amounts of data, right? So we're not talking about millions of data points. We're talking about like billions of data points. It's extremely large data that's very hard to analyze. And it gets into this idea of scalability. So in general, scalability of your system is important to consider when working with big data, because your system needs to be able to work even as you're using more and more data. This also kind of gets into some stuff that we're going to talk about in Unit 10 in regards to parallel and distributed computing. So for your questions, why does working with big data create new challenges? Big data, sometimes it's too large to process on a single computer. It might require cloud computing or parallel systems to help us do it. This talking about open data, it's good. It allows others to analyze information. It allows others to identify problems and hopefully develop solutions to problems that the original data collectors might not have considered. Make sure you understand the difference between crowdsourcing and citizen science. Crowdsourcing focuses on gathering input or data from many people, while citizen science specifically involves public participation in scientific research. And then why is scalability important when working with large data? Again, this is just as that data set grows, systems must be able to continue functioning effectively without failing. So kind of your takeaway from this is that big open crowdsourced data expand what we can learn from information. It also introduces challenges related to scale, accuracy, and data management. All right, so lesson 6 gets into machine learning. So there's a difference between machine learning and AI. We're not really there yet with AI, but we're getting closer. Really what we're doing now is this idea of machine learning, where we're writing algorithms. Those algorithms are running, and they're kind of learning on their own, but it's not considered artificial intelligence yet. So there's a couple videos for you to watch on this one. Those are linked on Canvas. But for your Cornell notes, for the machine learning, that's a process where computers learn patterns from data rather than being explicitly programmed. So we do program, we write algorithms, but the goal of these algorithms is to learn and find patterns for us, right? Humans, we can analyze a few data points. These machine learning systems, they can analyze millions of data points and give us more accurate results. When we're talking about training data, this is the data that we use to teach machine learning systems how to make decisions or predictions. So essentially, we kind of get the machine learning up and running, and then we start feeding it massive amounts of data. That is the training data. So using that training data, it starts running and starts finding these patterns. And then as it keeps going, it gets more data and it gets better and better as it goes. So there's this term called model. That's a system created by machine learning that uses patterns and data to make decisions. So essentially, the machine learning is trying to create a model or this system that it can use to find patterns. And all of this gets into this idea of bias, specifically bias in machine learning. So what we have to be careful of is that training data that we feed into our machine learning system to build this model, we need to try our best to make sure that it does not reflect unfair patterns in the training data. If there are bias in the training data, our machine learning will build a model that is then biased, right? That's the concept that you need to understand there. So we want to really try to make sure that training data, it comes from multiple sources, whether it be social, political, economical, so that it can build an accurate model and not a model that contains bias and thus, perpetuates that bias forward. So as far as how do machines learn using machine learning, they analyze training data, they identify patterns, and then they apply that to new data. Right? Why does the quality of the training data matter? Again, if the training data is incomplete or biased, the model will produce inaccurate or unfair results. So how can machine learning systems reflect human bias? Basically because they are trained on data created by humans, right? All the machine learning does is replicate the existing training data that it receives. So if that training data has a bias in it, the machine is going to replicate it. Then the last one, why is bias especially concerning in machine learning systems? Because bias systems can unfairly impact, different groups and reinforce different biases that exist in society. So we want to try to make sure that we can avoid that as best we can. That whole topic gets into a whole bunch of different points. Like if you start studying machine learning more, you'll learn about, human in the loop, human on the loop, human outside the loop. It's all like, where does the human come in to see and check on that model that the machine learning has built? But you just kind of need to understand that there is potentially bias in the training data. If that bias is presented to the training model, it will essentially teach the computer the bias, and the computer will perpetuate that forward. So kind of like your takeaways from this, lesson 6 is really that machine learning systems learn patterns from training data, which means that their accuracy and fairness depend heavily on the quality of the data that they're trained on, right? So then lesson 7 kind of gets even more into this idea of algorithmic bias. So your first term on there is algorithmic bias. That's when an algorithm produces unfair outcomes due to biased data, design choices, or assumptions. The second one is discrimination. So discrimination, everyone should know that it's an unfair treatment of individuals or groups based on characteristics that they have. And then representation is how individuals or groups are shown or or included in data or systems. And all of this kind of gets to this whole idea of machine learning and automation, which is the use of computers to perform tasks without human intervention. So what they want you to get from, lesson 7 really is that algorithms can unintentionally reinforce bias, especially when automated systems rely on biased data or remove meaningful human judgment. That's kind of like your takeaway, right? So looking at the questions, how can algorithms unintentionally discriminate against certain groups? It comes down to that training data, right? So we want to try to make sure that training data is unbiased so that our model runs correctly and produces fair results. Why is automated decision making risky? Obviously, automated systems can be biased decisions at large scale without human oversight. So the human needs to be involved somewhere, whether it's in the loop, on the loop, or outside the loop. And then why are some decisions better made by humans rather than algorithms? Some decisions involve context, fairness, and personal representation that algorithms may not handle appropriately. All right. So again, that's kind of your quick overview of lessons 4, 5, 6, and 7. Again, this one, it's really just about knowing those terms and understanding those concepts. So if you have any questions, come by my room. Otherwise, I look forward to seeing you at your weekly check-in.